Hello, this is Tracy. Welcome to MAT135 Introduction to Statistics. Today we are going to talk about some topics in probability. This is Chapter 3 in our text, and I will be going over this in a couple of different lectures here. So in this chapter, what we're going to be looking at is the vocabulary of probability. We're going to learn some words and what they mean, determine probabilities, use the addition and multiplication rules, and determine conditional probabilities. The text practice problems that I recommend for this chapter are listed out here. Alrighty, so we are going to talk here about some of our definitions. One of them is, I didn't write it here, but an experiment. And in probability, an experiment is different than what we talked about before, experiments versus observational studies. In probability, our experiments do not require a treatment. An experiment is simply doing something over and over and recording the results. So flipping a coin, rolling a die, pulling a card from a deck, spinning a spinner, something like that. Or an experiment can be gathering data on a lot of subjects. So an experiment in probability is a lot like an observational study in statistics. I know, it's confusing. It'll make sense once you practice a little bit. So an outcome is the result of an experiment. Rolling a die, the outcome could be the number that you roll, a 1, a 2, a 3, a 4, a 5, a 6. The sample space is the set of all possible outcomes of an experiment. So not just, well, my outcome is rolling a 6, it's the list of all of those outcomes, 1, 2, 3, 4, 5, 6. An event is a subset of the outcomes in a sample space. Our event could be rolling a number greater than 4. So our event would be rolling a 5 or a 6. So here what we're going to do is we're going to determine the sample space for some experiments here that are given. So let me get my pencil, and ooh, we don't want it in yellow. Let's make it dark blue. So if we roll a 12-sided die, what would be our sample space? In this case, our sample space, and we always use S to represent our sample space, would be the list of all possible rolls you could get on a die with 12 sides. So you could get a 1, a 2, a 3, all the way up through 12. That's our sample space. If our experiment is flipping a coin and recording the result of the toss, our sample space would be all possible tosses. So in a coin, you only have two possibilities, heads and tails. Well, tails or heads. Here, we are going to roll 2 4-sided dice, and we're going to record the sum. What do you get when you add what you have showing on the 2 dice? Now here, what we've got down here at the bottom is the possible outcomes for rolling 2 4-sided dice. You could roll, for example, a 1 and a 1, and the sum would be 2. You could roll a 2 on your blue die and a 1 on your red die, and the sum would be a 3, and so on. So if we look at these possible sums, well, some of them are repeated, but the list of possible sums, well, the smallest you can get is a 2, 1 on each die. You can get a 3, a 4, all the way up through a maximum sum of 8. So these are our possible outcomes. Notice they are not all equally likely. There's only one way out of these, if you count them up, 16 possible rolls to get a sum of 2. But there are 2 ways to get a sum of 3. So it's more likely you would roll a sum of 3 than you would roll a sum of 2. Okay, next page. Here what we are looking at is we are going to look at some events, some possible events out of the sample spaces that we looked at before. So V is the event that you roll a 12-sided die and you roll a value greater than 7. So here we would write our event as V, and we would list all of the outcomes, the subset of that sample space we have, that involve rolling a value greater than 7. Well, that would be our values 8, 9, 10, 11, and 12. 12, 12 outcomes in our sample space, but only 5 in this event. H is the event that you flip a coin and you get heads. So H would just be heads out of that sample space that had heads and tails. Here, when we roll those two four-sided dice, we're looking at E as the event that you roll two four-sided dice and you get a sum greater than 5. So out of those outcomes in our sample space, which sums are greater than 5? Well, if we look down here, 2 isn't, 3, no, not a 4, 5 is not greater than 5, but you can get a 6, a 7, and an 8 that are all greater than 5. Now we want to talk a little bit about probability. So probability, the probability of an event is the likelihood. It is the likelihood that that event occurs. So, let me get up in here. Probability of an event is the likelihood that that event occurs. Another way we can think about it is if you do something over and over, if you take the long term, over and over in the long term, relative frequency. Now remember, your relative frequency is the proportion of times that a particular event occurs. How often do you get that event out of all the times you tried? What percentage? Is it 10%, 25%? Is it 0.75 of the time? That is another way of looking at probability. Probability is always represented as a number, either a decimal or fraction, between 0 and 1, or equivalently as a percentage between 0% and 100%. If an event has a probability of 0 of rain tomorrow, probability of 0 that you're going to win the lottery because you didn't play, then that event is what we call impossible. A probability of 0 means that what you are looking at is impossible. Impossible. On the other hand, if an event has a probability of 1, then that event is certain. The probability of 1 that it's going to rain today. There's a 100% probability that it's going to rain. Completely certain, guaranteed to happen. And if an event has a probability of close to 0, not 0, but pretty darn close, then it is unlikely. Improbable. You could even think of it as unusual. If that probability is close to 0, the probability of an event is close to 0, that event is probably not going to happen. If an event has a probability to close to 1, then it is likely, it is probable. We will probably see that event happen. If, when you're doing your calculations, you ever get a negative probability or a probability greater than 1, then you made a mistake. You better go back and fix it. Figure out what the heck you did wrong, because you cannot get a probability negative or greater than 1. It just can't happen. That means a mistake occurred. Go back and fix it. So here we're just going to talk about a couple of different ways that we can determine probabilities. The three main ways to determine probabilities are, first of all, experimentally. And what that means is that we actually do something over and over and we observe the results. The probability of an outcome, a given outcome, one possible result of your experiment, is the number of times that outcome occurs divided by the number of trials you have. How many times do you roll a 1 when you roll a six-sided die? A gazillion times. Another way to think of that is that we could, instead of doing something over and over, we gather data from a large number of subjects and use that to help us make predictions about similar subjects. The probability of an outcome, the probability of having blue eyes. You look at a bunch of people and you record how many have blue eyes divided by how many people you looked at. And that will give you a probability, an experimental probability of a random person having blue eyes. Another way to determine probabilities is theoretically. And here we would calculate our probabilities based upon rules of probability. The third way we can determine probability is subjectively. We use our relevant knowledge and experience to make predictions. What do we think is going to happen based on our years of experience dealing with the situation? Now, these can be really accurate if you have somebody with a lot of experience and some good sense of what's going on, or they can be completely useless. All right, in the next lecture, what I'm going to do is I am going to go over how to calculate some probabilities and a little bit more vocabulary. Until then.